This particular problem from ISI Entrance 2019 is actually quite simple. It starts with this equation, cosine of sine of x is equal to half, and x is given to be between 0 and 2 pi. Before we go into the solution of this one, and you should really try this because this one is actually quite simple, let's look at the fundamental principle behind creating these problems, creating this type of problems. So maybe you can play a game. You can actually create some problems of this kind of your own. And what is the principle behind this? Well, take two different type of functions. In this case, we have a trigonometric function, two different type of functions. So here there is a trig function, and here we have a constant function. So take two different type of functions and put them into equality. In fact, you can also make inequations out of it. So let's create a dummy problem like this. Suppose you want to use two different type of functions. Let's say cosine of x equals e to the power x. You use two different type of functions. One is a trig function and the other is an exponential function. And you only know so many type of functions. There are not many type of functions that are usually coming up in pre-college level. So there is only a few ways of really creating this type of problems. And then you look at the domain. The trick of solving these problems is you look at the domain, and that's the method one. You look at the domain and there is usually a mismatch. Search for some sort of a mismatch. Maybe the domain of this or the range of this doesn't work with the domain of this or something like that. I'm not particularly this particular problem, but in general I'm giving you a general idea. The second method could be this, that you use a bit of calculus. So you create an auxiliary function. Let's say f of x equals to cosine of x minus e to the power x. So bring it to this side, and you want to know whether this function is monotonic or not. So maybe you can take a derivative of it and then check the increasingness or the decreasingness of this particular function. That also helps. So whenever you get this kind of a mixed bag problem, I call it mixed function problems. These are the two standard ways of attacking them. You either look at the domain and look for a mismatch, or you use calculus and you create this type of auxiliary functions and take the derivative. If the derivative is monotonically increased, if the derivative is always positive, then you can sort of say, okay, there is only one solution. Why? Because if it crosses the x-axis, it will never cross the x-axis again. It will keep on increasing and so on. So this sort of a standard technique can help in solving these problems. And particularly this problem from ISI Entrance 2019, which is much easier. So let's look into that. A link in the description will also help you a little bit with some extra problems and ideas. So cosine of sine of x is equal to half. We are trying to find x. That's the basic question, and we are looking at the domain of 0 to 2 pi. So we notice immediately that sine of x is between -1 and 1 if x is between 0 and 2 pi. Well, for any x it will work, but particularly for x between 0 and 2 pi, this will definitely work. Sine of x will be between -1 and 1. Alright, so now the question is this: when is cosine of theta half? Between 0 and 2 pi. Between 0 and 2 pi, when is cosine of theta equals to half? Well, actually you are not supposed to look between 0 and 2 pi, because this theta, which is in our case sine of x, This is ranging between -1 and +1. So you are interested to look at theta between -1 and +1. Okay, but we know that theta, cosine of theta is half if theta is equal to pi over 3. I mean, it's obviously true for other values, but that's the closest number to 1 for which cosine of theta is half. And what is pi over 3? Well, pi is approximately 3.14. So pi over 3 is this, which is a little bit larger than 1. It's a little larger than 1. 3.14 divided by 3. So this theta never reaches this pi over 3 value. It sort of is stuck between -1 and 1. It never hits pi over 3, so it can never become 1/2. So we looked at the domain of cosine and sine and used that domain and range. So we looked at the domain of cosine and the range of sine and looked at a mismatch between them to conclude that there are no solutions. This one is easy, but in general these problems can be a little bit more challenging. All right, keep on solving great problems. I will see you in the next video.